one critical component, that single source, is going line down. So we need to redesign that part of the circuit. And now you need to start all of those certifications over again.
Yeah, that would suck. But something that happened to me.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today, two trusted industry experts lay out, pun intended, the basic design milestones to prepare your circuit for production. After our recent episode on prototyping, a number of you reached out asking what are the steps involved in preparing a design for manufacturing. And while I had the general idea, testing, design for manufacturability, BOM optimization, as an applications engineer, it was nothing I'd ever had to worry about. So rather than guessing, I decided to invite to the lobby today two experts in electronics manufacturing. Our friend Mark Hughes joins us from Royal Circuits to share his perspective from deep inside the trenches.
A new engineer is going to be so overwhelmed by the amount of information coming at them, by the number of variables they have to balance, that they're not going to be able to consider DFM except as a separate step in the design process.
But first, Dr. Dongkai Shangguan is an IEEE Fellow and an IMAPS Fellow with 30 years of experience leading R&D in global electronics manufacturing. Throughout his career, Dr. Shangguan has accelerated the introduction of innovative technologies and products into high-volume manufacturing. Dongkai, thank you so much for joining me in the lobby. So you've had this legendary career, which includes working at an automotive electronics OEM, then getting involved in IC packaging, and then bringing all these talents to one of the leading electronic manufacturing services companies, or EMSs. You're decorated with all these industry awards. You've served on boards of industry associations like IEEE EPS, INEMI, IPC, and a few others. And you even shared your experience, your expertise, rather, through books and papers, keynote speeches. And man, this list just goes on and on. So with all of that in mind, this might seem like an oversimplified question, but let's assume that we have completed our prototype design and we verified that all the components are available. We think we're ready to manufacture the board. What is the first step after validating the prototype?
So I would say that, if you have selected your EMS partner, you start engaging with their team, where you start, I would start with like a DFM review.
Design for manufacture review. Okay.
Right. So because, most of the time designers are in one company and manufacturing is taking place in a different company. And the design team may have never been to a manufacturing factory. And so manufacturability may not have been the number one priority for the design team. So now we are going to bring the product to manufacturing, high volume manufacturing. Manufacturability can become a very critical issue. So I will start with a DFM review and make sure that the manufacturing engineering team look at the design and make sure that the design meets the design rules, DFM rules, and such that when the product is introduced in a high volume manufacturing, it can get to high yield and low cost and reliability and all of that.
Right, because that's a good point, actually. Not every design team is sitting in the manufacturing location or working side by side with the manufacturing engineers. So what you're saying is start with the DFM process to make sure the design is reliable, cost optimized, and will be produced with the highest yield.
Also, the EMS can make the recommendations about how you might be able to improve your design using alternative processes, alternative designs. And so optimize the design for manufacturability, for high yield, for cost, and for many other benefits.
When you begin the DFM stage of the process, are there certain guidelines for the types of applications that you're working on, or is there?
Right, that's a very good question. By the way, when I say DFM, I really mean DFX because there's a design for test as well, DFT, design for testability, design for other attributes, design for cost, reliability. But I'm just using DFM manufacturing as an example, right? So many companies have DFM guidelines or design rules. What is the component spacing? What is the through-hole size and pad size? And many other things. Very, very detailed design rules for different components. BGA, different BGA pitch, and CSP. And normally there is a EDA tool and that help automate the DFM review process. Mm-hmm. That would drive the review using those specific design rules to check the design, each individual design, make sure that all the design features meet the design rules.
And when you say making sure that all of the different aspects of the design meet the design rules, yes, it's for things that you just mentioned, pad size, pad spacing, component footprints, but also the CAD software is checking for things like trace dimensions, spacing, and so on.
Right. I mean, there's a PCB fab design rules, and there's mechanical assembly rules, and et cetera. For different process steps, there are specific design rules.
Oh, wow. Okay. So even assembly, all of this is specified in design rules.
Right.
And then in the real world, you made a really good point about design for sort of cost optimization. So maybe taking a look at, are we introducing more components on here that we need, or the, more expensive components?
Right. And also maybe process steps. If it involves very complex mechanical assembly, for example, you want to look at the assembly steps, tolerances, you want to look at accessibility, and then there may be some that are based on the experience of the engineers that they can leverage to give you the recommendation as well.
And like you said, there's a lot of human intervention in this as well. And there are the EDA tools, but I think the wisdom that comes with human experience is probably a major part in any of these design for X exercises.
Right. And, it's a human experience assisted with the EDA tool.
So tell me about partnering with the EMS engineering teams, which you mentioned earlier.
So you start with the DFM review, and that hopefully give you a very good partnership between your design team and the manufacturing partner. And then you go from there, and you get into NPI, new product introduction. And once you reach a certain volume, certain yield, then you ramp up and get into a higher volume.
Yes, and when we are talking ramping up into production volumes, that's where a long-term partnership is especially beneficial. And at production volumes, let's say it's 1 million units per year, right? Even 1/10 of a cent added to the manufacturing cost can make a real impact on your margin.
Exactly, and many products today are made not only in millions but probably in billions, so in terms of the number of units. And so that cost per unit really can multiply very fast.
This episode is sponsored by Molex. As a global provider of electronic connectivity, Molex continually adapts to help customers advance technology in the areas of greatest impact. For those with a shared mission to create breakthroughs that propel the world forward, Molex knows that any challenge can be overcome and pursues that progress with unmatched determination. Learn more at molex.com.
In your experience, do a lot of engineers, are they good about designing forward, knowing that they have to make this a high yield, highly profitable circuit design? Or do they look at the functionality more than anything and then are surprised later by things like cost optimization?
I think it depends on the individual designer, his or her experience. Also depends on the maturity of the product. And because, I think most of the time we're talking about startups, and it's the early stage of a startup. Your main objective is to design something that works. And so functionality is a high priority. And over time, as you have proven the design, the functionality, the priority is shifted more towards, manufacturability, yield, and cost, and reliability. And then, of course, the things we just talked about become more and more important. And, it's a learning curve. It's a learning curve for each individual as a professional. And it's a learning curve for a new company. It's a learning curve for each program.
Totally. Yes, totally. A learning curve for each person, for each company, and for each program. That's exactly right.
And hopefully, with experience, with, the collective knowledge, the learning curve can be accelerated.
Yes, and you accelerating that learning curve means eventually you will bump into the limitations of your capabilities, and there will be an unsuccessful outcome, but you take away and you understand, okay, so next time we design this, we are definitely going to have to look out for these factors, and you keep accumulating that wisdom throughout your engineering team.
And right, and also very importantly, we want to have a long-term partner, a EMS partner that can work with you, not only just do your manufacturing, but hopefully can engage with your team early in the product development cycle and give you recommendations and DFM reviews early in the design
Exactly.
cycle.
So engaging your manufacturing partner early enough in the design process that you can design these things efficiently.
Right, exactly, because it's a lot easier. It's a lot more cost effective if you make design change early in the design cycle.
Exactly.
Versus, finish all the design, you build a prototype, you test it, then you give to somebody else to do the DFM review. They may come up with a lot of very good recommendations, but you say, oh gosh, it's too late for me to change because it's going to cost money, it's going to cost time. So it's too late.
A key mistake, a fatal mistake that an engineer could make is waiting too long and making assumptions about the manufacturing worthiness of their design before they get in touch with a manufacturing partner.
Right. So that's why you need the partnership. You need the trust in between the design team and the manufacturing partner.
Are a lot of the engineers at the manufacturing service companies, whether it's, Jabil, Flex, Foxconn, whoever, are a lot of those engineers also familiar with the design engineering and are equally experts in the manufacturability, or do they have more expertise in taking an existing design and making it manufacturable?
Well, I mean, certainly there's a lot of expertise in the EMS companies in high volume manufacturing, DFM, and optimize design for manufacturing. But more and more, I think over the past decade at least, there has been very, very strong design engineering expertise in the EMS industry as well. You mentioned ODM. Many of the EMS companies are doing design as a service, either a complete design or pieces of a design, depending on the relationship. So many EMS companies have strong design engineering experience and the teams that can be leveraged.
Yes, I've noticed that. I know when I first started in the industry a little over 20 years ago, for the most part, the EMS companies that I was dealing with, and more in the industrial electronics space, really wanted to take a complete design and then take it from test and into production. They didn't offer too much front-end design service, but over the years, I've seen a lot more EMS and ODMs offer very strong design engineering capabilities as well.
Yes, so the industry certainly has evolved and made a lot of progress. And exactly as you said, 20 years ago, EMS is just a outsourcing supplier for capacity overflow. Mm-hmm. In those early days, many of the OEM companies were doing manufacturing themselves. Mm-hmm. But when they run into capacity issues, they go to a EMS. But, that was 20 years ago. And since then, so many things have evolved and a lot of progress has been made. And EMS companies have taken on more and more technology capabilities and design engineering expertise and a lot more to offer today in technology, in engineering, in design support and services, and can really be a very, very strong innovation partner for the design community.
Yes, absolutely. Absolutely agree with that. Let's talk for a minute about agency compliance and agency approvals, because, at some point, this will either need to be a product that passes UL or CE certification, FCC certification, whatever the case may be. Is this something that occurs after you've done the DFM and verified that, yes, I'm certain that this is the most reliable, cost-optimized circuit, and now we go into agency approvals, or is that done well beforehand?
I would say if you look at the certification, right, then on the one hand, there is certification for the EMS partner for their operations. There's automotive certification, there's medical certification, and others. So many of the factories of a EMS company have some of these certifications for their manufacturing operations. Then you also look at the product certification, the ones that you just mentioned, Dave, like FCC and other CE and UL. These are more product specification for each specific product. And there, once you build your prototype and you finalize your design, I think that's where you can engage with an agency or certified lab to perform that product certification.
Right.
And because you need that before you ship products.
Exactly. Get the design right up front, get it manufacturable, and then get the agency approvals as sort of a later step.
Right. And you don't want to do it too early, because if you're going to change the design, then you have to do this all over again, right? So you want to do it as soon as you have finalized the design, right? You have done your DFM review and reliability test. You say, well, that's a design I'm going to take to the market. You want to do it as early as possible because it takes time. Some of these take quite a few months, right? So you want to get it started early, but not too early. You want to do it only after you have finalized the design.
Also, again, another reason why it pays to have the manufacturing partner engaged as early in the process as possible to avoid these lengthy delays in the in the design process.
Right. Early engagement is a key word here for a good relationship, if you really want to leverage the value of your EMS partner.
Yep. There's also cost out. So you mentioned earlier in the conversation, the first generation of anything will probably not be the most cost optimized. It'll probably be the most electrically functional for that given set of features. But I think maybe in a company's efforts to get a first generation product out the door quickly and into the hands of consumers, they have opportunities they discover to maybe further cost reduce in the second generation and beyond.
For sure. I mean, for every product, there is a cost curve, right? At the beginning, there's this novelty factor. Mm-hmm. So you can afford to, sell at a higher price. So your cost pressure is not so high, right? But over time, as the product become, more mature, novelty factor dissipates, And so you have price pressure, then that translates into cost pressure. And so those cost optimization efforts becomes very critical. And there, the EMS company can offer value engineering. Work with you, see how the product design can be optimized. The components can be replaced with alternative lower cost, but same functionality parts are optimized for cost as well.
Right. Have we left anything out? Is there anything else that an engineer should know if they're going into a role where they're going to be designing products that will be manufactured?
I think we covered the most important areas, Dave, and I would just encourage design engineers to engage with EMS partner and see what they can offer, so your design team can focus on their most value add and then leverage the partner for everything else.
Orion Fans, division of Knight Electronics, designs, develops, and manufactures a broad line of AC, DC, and EC fans, fan trays, fan accessories, motorized impellers, and blowers to meet the continuing thermal management needs of OEMs worldwide. Fast responses, short lead times, and better inventory management programs result in lower inventory carrying costs for you. With the quickest response, largest available fan inventory, shortest lead times, and competitive pricing, Orion Fans will deliver the exact cooling solution you need, fast. Orion Fans. We'll make you a fan. For more information, go to orionfans.com.
Our next guest is a good friend of All About Circuits and even joined us on our very first episode of Moore's Lobby earlier this year. Mark Hughes is Research Director at Royal Circuit Solutions in Hollister, California. Mark, welcome back to the lobby. My experience, I never had to design anything where I was the one responsible for its manufacturability. As an application engineer, I could provide pseudocode, I could provide reference schematics that were so not optimized. And it was just assumed that there would be some other design team who would take that and say, thank you very much, this is how a Class D amplifier works. And then they would get it ready and make it productized. So I can speak from personal experience. I never even considered what would go into manufacturability.
Somebody who's got years of experience in this, it's ingrained in them. It's part of the design process from the very, very beginning. A new engineer, though, doesn't have that capability. A new engineer is going to be so overwhelmed by the amount of information coming at them, by the number of variables they have to balance, that they're not going to be able to consider DFM except as a separate step in the design process. There's just too much.
What would your advice be to that inexperienced engineer who's listening to this thinking, oh, this thing's going to have to go into production, and I don't even know what that looks like?
That's a great question. So some shops like mine at Royal Circuits, we offer free engineering. It's a value-added service. You've got a question, and we'll put you in touch with the line engineers that are going to have to make this thing, and they will walk you through how to make things better, cheaper, faster, whatever. To give you an example, one of my favorite Royal Circuits employees, named is Elijah Gracia, he got a board in, and he saw that the designers had included a single buried via. He went and he talked to them and said, guys, this is going to really increase the cost of your board. Is there any way we could maybe do a different arrangement and create a blind via at least, or something along those lines? And he went back and forth with them a couple times, and then he finally found out enough about their design. He said, just make it a through-hole via. Now, we were making 1,000 panels or something like that. But that simple removal of that one buried via from the design saved that company $50,000 on a 1,000-panel order.
And that's exactly the kind of thing I'm talking about, where I was probably the first person to just think, well, this is a cool way to solve this problem, not even thinking about, the cost that adds, or even maybe reliability issues, maybe not in this case, but in, there are so many factors.
Yeah. So Get out there and see how boards are built. Talk to the engineering. If they offer engineering services, make use of them. One of the things that we've been doing lately in the time of COVID is offering free webinars to companies. So they just call us and say, hey, my skill set's a little weak in, designing for manufacture. Can I put my engineering team on with your engineers? And yeah, we set up the web call and they ask whatever questions they want to ask and we answer them. So find out if your company has that availability. In my experience, most of them will talk to you. Some more than others, it just depends on how needy you are, but talk to the company that's going to build your board.
Can you think of any spectacular failures that have arisen because somebody said, no, my design is perfect, just go build it?
Oh, yes. Yes, I have. There's another podcast that you might not be aware of, and it's Mike Conrad, Aqueous Tech. His podcast is Reliability Matters. He's got this great example of a lawsuit that happened between a contract manufacturer, right? This is an assembly house, and a company. And the reason was the company had their products fail, and they were, let's say, obnoxious about the way they were treating the assembly house, saying, no, I build it the way I told you to. Assembly house went back and said, we really don't think this is a good idea, but you're the customer. And the assembly house was very much trying to help the customer out, and the customer just told them to stuff it. So they built it. The product failed in spectacular fashion, and the company obviously wanted their money back, and the assembly house said, listen, we just did what you told us to. Yeah. And the lawsuit was, well, you should have known better. You should have not listened to us. You should have pushed back harder.
Oh.
Mm-hmm. And I would say that every time that I am walking through the shop and I see artwork on a screen, a layer artwork, or I see a design, I can oftentimes look at it and say, I wouldn't do it that way. And sometimes it matters and sometimes it doesn't. But the times that it matters, it's usually where we can save the customer, depending on how many boards they order, 4, 5, 6 figures of cost, if they would just be willing to listen to our guys.
Mm-hmm. I suppose an even worse case would be you finish your design, or so you think, you get it through all the certifications that you need, and it's all the compliance and regulatory stuff, it comes back approved. And then they say, oh, but you know what? We just found out that this one critical component, that single source, is going line down. So we need to redesign that part of the circuit. And now you need to start all of those certifications over again, right?
Yeah, that would suck. But something that happened to me, not even that long ago, it was March of last year, I had a design and the manufacturer is like, oh, you have to use this chip. It's great. We went through all the specs. It really is a fantastic integrated circuit for what it did.
Mm-hmm.
And I got through the design and everything relatively quickly. I think it was 3 months from, even just starting to talk about the project to having product in hand. And as I was about to have some more built, to start selling them, I talked to the manufacturer and said, hey, this is great. You were right about this chip. It outperformed in every metric we have. And he's like, yeah, I got some bad information for you. I was like, what's that? Well, the ASIC manufacturer is no longer going to produce that chip.
Oh, no.
Chip.
The ASIC, by the way.
Yeah. Application specific integrated circuit. Yeah.
Right.
It's done. You're done. And
you're not going to find a lot of those in the catalog.
No. And I'm like, really? Like, yeah, well, that's unfortunate. And I'm like, remind me again, you told me to use this chip, right? He's like, yeah.
And see, that's why I was always just as pleased as could be to be in the application lab thinking like, glad this isn't my headache. Oh man, that's the nightmare scenario right there.
Yeah.
Well, but it is kind of bringing to life a really good point you just made, which is that I think a lot of us have EMS or assembly houses, a picture in our head of you send us the design and we just print it, right? But It's not that. It's you do have engineering resources on hand, and these should be thought of as an extension of your design team, if for no other reason than to get yourself into production faster.
By all means.
Yeah.
These people, all they do all day are make boards. Maybe a good engineer, somebody who's pretty busy, maybe they put out, 6 to 12 designs a month. Well, our engineers see 6 to 12 designs a day or more. So absolutely use the line engineering and the CAD CAM engineers as an extension of your resources. And in my experience, they're often happy to help. They might be busy, might take a little while for them to get back to you, but get them on the phone. They love to share. They love to save money.
Hey, what would you say are like the top 3, if you could identify the top 2 or 3 CAD or EDA packages that you work with or that you see your clients working with?
Oh gosh, certainly Altium,
Okay.
Cadence, the Cadence tools, the Altium tools. Now, for a third, I would probably say, just because we get so many orders from a certain conglomerate, that you're probably looking at Eagle or KiCad or one of the lower, I would say, entry-level tools, just based on volume alone. But I would say the professional engineers are on mostly professional tools. The Altium Designer, which is a fantastic tool.
Mm-hmm.
I can't afford it myself, but it's great.
Right.
And then the Cadence Allegro ecosystem is up and coming as well. That's pretty popular. So if you talk to Altium, and you really should, because they've got great people. Instead of looking at design for manufacture, which is, as we talked about earlier, a lot of people just think about that as a pass you do at the end of the design process.
Yeah.
Really what they're looking at with Altium is design with manufacture, right? So we can have constant back and forths with the customer through every step of the design. So as they're going through, they have a question, they send it over to us, we can answer it for them, send it back to them, and we can have back and forths. That's really what the direction that Altium's aiming. They want you to be intimately involved with your fabricators from the very beginning.
So it is worthwhile for obviously any engineer, but certainly the younger engineers, to get acquainted with these sort of enterprise grade design tools and ecosystems.
Yeah, and it also makes them a more valuable employee. Remember that board design is often not taught in our major colleges and universities. You can get a degree in electrical engineering, a bachelor's degree, having never built a board.
That's right.
Which I think is criminal. I mean, what else is electrical engineering if not design? So if you're not training these kids how to do it, I mean, what are you doing? But that's what we're doing. Right. So I would say if you're a young engineer, find a way by hook or crook to get your hands on that stuff. Form a club, build a robot, contact Altium, and they will find a way to work with you. I promise you that. You have to develop a intimate understanding of how we're going to make your boards. Are we going to use cap or foil construction? Are we going to, how are we going to make your vias? Are we going to tin, all of these things? You have to slowly develop that understanding. And you're not going to be able to catch it all the first time you go into a board shop and look around. You're not going to be able to pick up everything. If you read articles, you're not going to be able to pick up everything. But grow that knowledge little by little, bit by bit over time, until you could theoretically walk in the shop and build your own board. You can develop this mental picture of how somebody would physically construct your board. Then you're probably making a board that's manufacturable.
So there you have it. Big thanks to our guests, Dr. Dongkai Shangguan and Mark Hughes, who joined us from their offices this week. Certainly cleared things up for me, but we'd love to hear from you. Have you developed your own workflows to prepare your designs for manufacturing? How early do you engage with EMS? Do you engage with an EMS at all, or is it all internal at your company? What sorts of things have you learned in this process? Drop your comments onto this episode's page on allaboutscircuits.com or connect with me on LinkedIn. And if you enjoy Moore's Lobby, please leave us a review on Apple, Google, Spotify, or wherever you listen to us. This is how we can build a meaningful community of listeners and contributors. Thanks for listening.